Welcome to Ask and Learn.
So we're dealing with chickens, and we have this gigantic food company that purchases 40% of its chickens come from the free range farm, and therefore 60% come from the big food farm. And we know that from the free range farm, 10% are less than 3 pounds, and therefore 90% are at least 3 pounds. And for the big food, 20% of the chickens are less than 3 pounds, and therefore 80% are at least 3 pounds. And we want to find the probability, and this is kind of A, we want to find the probability that given that you've got a chicken that weighs under 3 pounds, what's the likelihood that it came from the free range farm? So we know we want to find the probability of free range and weighs less than 3 pounds divided by the probability of weighing less than 3 pounds. And the less than 3 pounds has two ways of happening, either this way or this way. And so this times this is the 0.4 times 0.1 plus 0.6 times 0.2. And so that probability comes out to be the 0.4 times 0.1 plus 0.6 times 0.2 comes out to be 0.16. And the part of that is the intersection, or that comes from the free range, is this 0.04. So we would have a 1/4 chance or a 25% chance that it came from the free range farm. Now, your next question, I'll call it part B, says that you get 5 of those chickens. And we know that the probability that it comes from the free range farm is a 1/4 chance. And we want to know what's the probability that at least 3 of them came from the free range farm. And so this is equivalent to, this is a binomial setting. And we know this is the chance that they come from the free range farm. And so you have a 3/4 chance of coming from the other farm. And we would have 3, 4, and 5. So we can do this with straightforward calculations of combination of 5 choose 3 times 1/4 to the third times 3/4 to the second. And then a combination of 5 choose 4. 4 of them are coming from that farm. 3/4 to the first power, and then 5 choose 5. All 5 of them are coming from that farm. So we can add those probabilities together, and we can also use a binomial CDF and do 1 minus the probability of a binomial CDF. This complement is 1 minus the probability that x is less than or equal to 2. And so we can use that CDF button or find 0, 1, and 2, and then 1 minus. But software-wise, it's easy to do it with this button. So that's what I'll type in. So 1 minus second distribution binomial CDF, and my trials are 5. Probability of success is 1/4, and we would plug in 2. And so I'm going to make sure I plugged in the 1 minus. Yes, I did. And so when we do this, we end up getting about a 10% chance of that happening.